Another simple machine that uses wheels is the pulley. Pulleys are used all the time for lifting things. Sailors use pulleys to hoist sails, which can be really tough when the wind is pushing against them. A pulley uses a cord or rope wrapped around a wheel that can turn. As we saw earlier, this allows the cord to move with very little friction. Pulleys can be used in lots of ways to increase mechanical advantage. Here's a fun experiment that shows how even a simple system of pulleys makes work easier. And you'll actually see mechanical advantage in action by the numbers. Start by making sure you have all the necessary materials. Several lengths of string or cord, 2 pulleys, a tall ring stand, a set of various hangable weights, and a spring scale. Take the first pulley and suspend it from the top of the ring stand. It will act as the fixed pulley. While we have just that one pulley in place, let's drape our line over it and tie one end to this 500-gram weight. How many grams do you think it would take to balance this weight in the air? First try 200 grams. Nothing. It didn't budge. Now let's go with 1,000. Okay, by now you've got it. 500 grams will balance perfectly. The single pulley operates just like a seesaw. Equal weights on opposite sides of a single pulley will hang in equilibrium. To figure the ratio of your mechanical advantage, you divide the output weight, that's the weight of the load, by the input weight, that's the weight you use to lift the load. In this case, the ratio is 1:1. Now here's the fun part. Keep the fixed pulley just where it is and tie one end of the string to the hook on the bottom. Suspend the second pulley, called the movable pulley, below by looping the string under it and then back up over the fixed pulley. You've created a pulley system, also known as a block and tackle. Now suspend the 500-gram weight from the movable pulley. Try to raise the weight by attaching various measurable weights to the free end of the cord. Add smaller weights until it balances. It should take about 250 grams. Now, double check it with the spring scale. Make a note. Output weight 500 grams, input weight 250 grams. This time, your calculation shows a ratio of 2:1. The mechanical advantage is 2. Now let's try another variation. Untie the string from the fixed pulley and this time tie it to the movable pulley. Now loop it up and over the fixed pulley. Then down and under the movable pulley again. Once again, attach the 500-gram weight to the movable pulley. Now, use the spring scale to pull up on the string to lift the weight. Note this weight and again figure the ratio of your mechanical advantage. By changing the configuration of the pulleys, you've now increased it to roughly 3:1. You've just seen how, by using a pulley system, a simple machine, you can actually calculate your mechanical advantage and how much force you'll need to lift a heavy load. It really works, and it really makes work easier. Some of the most dramatic applications of pulleys can be seen in giant cranes. They use elaborate pulley systems to distribute the weight of huge loads by multiplying the number of strands in the pulley many times. In fact, the pulleys give them so much increased lifting power that they have to use steel cable to support the very loads they can hoist.